Hello and welcome to another episode of Mr. Boskin Does Some Math. Today we're doing Illustrative Math, Grade 8, Unit 2, Lesson 4, Practice Problems. Okay, our first question here says, triangle ABC is dilated using D as the center of dilation with a scale factor of 2. The image is triangle A prime, B prime, C prime. Claire says the two triangles are congruent because their angle measurements are the same. Do you agree? Explain how you know. Well, congruent means the same shape and size, and these two triangles might be the same shape because they are a dilation of each other, but they are not the same size, so they are not congruent. They're different sizes. On graph paper, sketch the image of quadrilateral PQRS under the following dilations. A dilation centered at R with a scale factor of 2. Do the first one in red. Even make that a little tinier so it's easier to see. Scale factor of 2. That means every side is going to be twice as long, and we are centered at R. So if we follow this out, it's going to be over here. And if we want to calculate it, from R to Q goes 1, 2, 3, 4, and up 1. We want to double that, so we want to go up 1, 2, 3, 4, and up 1 again. So that's going to be there. S, up 2 over 2, up 2 over 2 more. P, point P, goes up 3 and over 2, so we're going to go up 3 more and over 2 more. So P is going to be here. Ooh, that's not my straightest line ever. So dilation centered at R, scale factor of 2. Next we'll do a blue one. Centered at O, which is down here, with a scale factor of 1/2. So point Q is up 3. We want half of that. Half of 3 is 1.5. So there's our new Q prime. R is up 2 over 4. We want half of that. So up 1 over 2. R will be right there. S, it looks like is up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So half of up 4 is up 2. Half of over 6 is over 3. And P is up 1, 2, 3, 4, 5 over 2. So we want to go up 2.5 and over 1. Again, all we did was we found how far away everything was from O and multiplied it by 1/2. Now we have a dilation centered at point S with a scale factor of 1/2. Well, point S is 0 units away, so the new one will still be at point S. From S to P is up 1 over 4, so we're going to go up 1/2 and over 2. R is down 2 over 2, we're going to go down 1 over 1. And Q is over 1, 2, 3, 4, 5, 6. and down 1, so we're going to go over 3 and down a half. There. Dilation center to S with a scale factor of 1/2. The diagram shows 3 lines with some marked angle measures. Okay, the first angles we can think about with this are vertical angles, which means the angle across from an angle when 2 lines meet. So if this one is 35, this one here also has to be 35. This one is 27 across from the 27, also has to be 27. Now, because this is a straight line, this angle and this angle have to have a sum of 180. They have to add up to 180. How do we find out what adds up to 180? We can just do 180 subtract 35 is 145. And to find out this one, these two also have to have a sum of 180. 180 subtract 27 is 153. Now, we've got a couple other vertical angles we can do here. If this is 145, this one has to match. If this one's 153, this one has to match. So we can fill in all the angles on these just using vertical angles and knowing that the sum of angles that make a straight line is 180 degrees. Describe a sequence of translations, rotations, and reflections that take polygon P to polygon Q. Well, that looks like we are going to have to rotate and then translate. Get that out of the way so I have some space to write. If I take this, I'll do it in a different color so we can see it. So, quick trace of polygon P. If I rotate that 90 degrees, where do I want my center of rotation to be? The center of rotation is a point that doesn't move when we rotate. So let's make that our center of rotation. I'll label it. Let's name that point A. So the first thing I did was I rotated 90 degrees clockwise about point A. So the next thing we have to do to get this rotated figure onto Q is translate it. Or, no, I think we just have to translate it. But how much do we have to translate that? Well, we have to go down 1, 2, 3, 4, and right 1, 2, 3, 4. And then this point will be here, and those are corresponding points. So if we go down 4 and right 4, that will put one figure onto the other. Translate down 4. and translate right 4. So that's describing a sequence of translations, rotations, and reflections that will take polygon P to polygon Q. Next question. Point B has coordinates -2, -5. So -2, left 2, down 5. That looks like our point is right there. That is point B. After a translation 4 units down, a reflection across the y-axis, and a translation 6 units up, what are the coordinates of the image? So first, we go down 4 units. 1, 2, 3, 4. That puts it right here. We'll call that B prime. What do we do? So we did that. Now a reflection across the y-axis. The y-axis is the vertical axis. If we reflect, we go straight across the axis the same distance. Ooh, that looks like my B and B prime were in the wrong place. Someone should say, hey, Mr. Boskin, pay more attention to what you're doing. Those were at an x of -3, not -4. There. I fixed it. Now, we were at -2, -5, which is where we started. We translated down, then we're at -2, -9, reflect across the y-axis. And now we are at 2, -9. I'll call that B double prime. Reflection across the y-axis, we did that. And a translation 6 units up. 1, 2, 3, 4, 5, 6. I'll call that B triple prime. And the coordinates of that point are 2, -3. Okay, that was our last question for today. This has been another episode of Mr. Boskin Does Some Math. Thanks for watching. See you next time.